Hi everybody, here we're going to go over the procedure for the friction lab experiment. So here, don't forget to enter your student ID. And next you're going to have a link here. So if you click on this internet link, then this first page is going to show up here. Actually, it would look like this when you load it. You just click on begin. And so there's going to be different things you're going to measure. You're going to measure mass, you're going to measure force, and you're going to measure angle. And you'll put the errors here. And don't forget to write your units and convert your units into SI units. Section 2 has a list of the different variables and symbols for the errors. And section 3 has the formulas that you'll be using for today's lab. So the lab actually begins here in section 4, and there's going to be 3 parts. So something else that you find is that there's going to be a handwritten set of instructions, and that's going to be here. So make sure you read the theoretical part because there's going to be some homework questions where you'll find the answer over here. But the procedure is going to begin over here. So there's going to be part A, there's going to be a part B, and there's going to be a part C. So part A and B, they're both using the first website that I just showed you. And so the first thing you'll do is you're going to do the experiment for part A with wood on a table. So what that means is that if you go to this page here, make sure you select wood on table. And part B, you'll repeat the experiment, but you'll do it with rubber on concrete. So let's go over the basic procedures. So once you load up this website, make sure you set the mass to 100 grams. And then you're going to begin the experiment. And so data is going to get populated here. And so this is going to be the force applied to make this block move. So you're going to measure 2 things. You're going to measure the amount of force right before the block starts to move. And you should read the theoretical part to see what kind of friction this corresponds to. And also this second force over here, where the force that as the block moves, that corresponds to another form of friction. And again, make sure you read the theoretical part to see the distinction between the force that this line represents and the force that this line represents. So once you get those 2 forces, then you're going to go over here. Don't forget to enter the mass. Convert the mass into kilograms or into SI units. Don't forget to do that. And depending on those 2 forces, there's a static friction force and there's a kinetic friction force. So you have to read, you're going to get that from the value of the force of this line over here. And as you can see here, this is the axis here. So you're going to have to you're going to have to read the theoretical part and decide which of these corresponds to the static friction and which corresponds to kinetic friction. And you'll enter your values over here. And don't forget your units for force. And next, you're going to calculate. You can calculate the normal force using the formulas that are defined here. So that's going to be for trial 1. So let's also do trial 2. So for trial 2, just reset and increase this mass here. So I think different people are going to get different numbers. So you just need to increase it once, and then you're going to repeat the procedure and get these set of data points. And then you're going to increase it again and put that value over here for the third one. Don't forget to convert, and with the corresponding values for static friction force, kinetic friction force, and then you're going to calculate the normal force and even the error for the coefficient of friction using the formulas that are listed here. And you're going to complete this table. So now after you completed this table, you're going to make a plot of one of these axes versus another one. I'll let you read to see which one you should be plotting. And once you do, you're going to get a graph of one is going to correspond. You should have 2 graphs on or 2 lines on the same graph. So you can compare just like we did for the last experiment. So you'll be able to compare the force for coefficient for static friction and the coefficient for kinetic friction. So you have to get those 2 graphs, and the slope of the graphs, one of them is going to correspond to kinetic and one of them is going to correspond to static. So you'll have to again read the theoretical section and even read the procedures for an explanation of which one corresponds to kinetic and which one corresponds to static. And so you'll get the error for each of these experiments using this formula here. And over here, this is going to be an average of those errors. And that's going to give you the average error for the coefficient of friction. And don't forget the units again. Part B, you're just going to repeat the same procedure, but just make sure you change it to wood on concrete. Just make sure it's, just pass it, make sure it's set to, rubber on concrete. That's going to be the one for part B, and you just repeat the procedure. Okay, so part C, this is going to be a different website, so make sure you click on this link here for part C, and it's going to take you to this website here. So let me just refresh that. So you'll click on begin, and this is what the website is going to look like. So here, you have some numbers that are generated. So these are randomly generated. So just whatever values you see here, make sure you enter those into kinetic friction and static friction, and even the mass of the block. Make sure whatever number you see here, so you're going to enter it there, 502, but just don't forget to convert that into SI units. And so what you'll do is just here, you're going to click on change the angles, and you're going to have to maybe if you zoom in here, you're going to look at this angle and see what angle, at what angle does this block start to move. So whatever angle you see, so it's somewhere around 20. So you'll enter that value there. And you're going to do that for different sets of masses. So you're just going to reset and then increase the mass. And then you're going to redo the experiment. So you're just going to get a range of masses, and different students are going to get different masses because these numbers are randomly generated. But whatever angle where the block starts to move, then you're going to enter that angle there, and you should get 5 different trials. And then the next part is just to calculate the tangent of these angles, and you're going to here you're going to actually over in this one here, you're going to get the average of those tangent values. And the last part is just you're going to compare, so in the theoretical formula, you're going to have to decide whether does the tangent of the angle, is it equal to static friction or is it equal to the coefficient of kinetic friction? So whichever one of these has the closest value to 0%, that would imply that the tangent is going to equal that particular value for the coefficient of friction. And also, you're going to calculate the average error for the coefficient of friction as well for this one. And also you have your homework assignments, so don't forget to do that as well. All right, so this concludes the procedure for the friction laboratory. So just don't forget to read these instructions in detail here so that you can do the lab but also answer the homework questions.